Hello and welcome to my video. I'm gonna show you a secure entry system that consists of two parts. You have to enter a PIN code and you have to press this button to open the door. Of course I haven't entered the PIN code, so the door won't open, and it is configured so that you cannot just place a button beside it and open it. No, you have to cut the power to the door to actually open it. Anyhow, let's do that. The correct code is 1321, and then the door will open. It will remain open until you go in and you see this extremely nice secret chamber. And when you're supposed to leave, you just leave. The pressure plate resets the system. No, it does not reset the system actually, but it does close the door and it keeps it open while you're standing on it, and then, well, the door closes when the button resets. So let's look at the wiring, shall we? It's perhaps a bit intimidating at first, but it's compact and it's actually rather simple. It consists of 4 memory cells that represent the PIN code's succession. You have to press the correct number, and each of these buttons are hardwired to a memory cell, and the first button being used twice is connected to 2 memory cells, the first and the last, and the second and third is cross-wired here. Each memory cell prevents the next memory cell in the succession from becoming activated using this repeater. Let's check that out. The second cell in succession would be button 3. 1, 2, 3. And it activates the redstone but not the memory cell, and that is because we haven't activated the first cell yet. Let's do that. The cell activates, the redstone is off, and now we can activate the second cell. And yeah, that's basically the idea. Some of the details should include, it's cross-wired down here, but basically it's just that the 4th button reconnects to the reset functionality, and this yellow line representing button 1 goes to the 4th cell as well. And it's protected by this repeater, which in this case acts as a diode, preventing this activation from trickling back to the 4th cell, so that you would have a 3-digit PIN code, which makes no sense at all. When all 4 cells are activated, it will turn off this redstone, and this inverter will provide a input to this OR gate, and the second side of this input, an AND gate. It will provide an input to this AND gate, and the second side of the AND gate is connected to the door control. And now that I haven't entered the correct code, it will just reset the system again, so you have to enter the code again. So let's see how this would work. Let me be on the upper side while I do this, so you can see it trigger. The first cell, the second cell, the third cell, and the 4th cell. And everything is open. The input to the AND gate is active on this side, and all we need to do is activate the door input. And it opens the door. This redstone leads down to a memory cell down below, which keeps the door open until we actually enter. This redstone here doesn't seem connected, but it is actually just below the pressure plate. So when you press it, it will activate this redstone. And this redstone in fact leads down to 2 parts. It does open the door first, and then it also closes the door. But since we do provide input on this side, the torch will be unlit, since it's connected there. And yeah, I suppose that's basically how it works. If there is interest, I can provide this world for download somewhere. I don't know where, but you could study it in detail, and you can also figure out how to wire the stuff differently to get another pin code. But the most important part is, as I said, these memory cells that has to be activated in succession, and these redstone repeaters that keeps the next memory cell in succession from being activated. This is actually rather more compact than the original video that gave me the idea. Yes, so I'm quite proud. Yeah, I suppose that's it. Bye!